Welcome to my YouTube channel Programming with DP1. Let's start with the analysis of the weekly contest 378. So start with the first problem. So the first problem from this contest is check if bitwise OR has trailing zeros. So in this problem we are given an array of positive integers nums. Here what we need to do, we need to check that if it is possible to select two or more elements in the array such that their bitwise OR operation is having a trailing zero. So as they have mentioned that at least one trailing zero is required. So first we will check the test cases, sample test cases. That here we can see that the array consists of 1, 2, 3, 4, 5 elements, and there is a possibility that we can take two elements and do their OR, and we get the trailing zero. So here they have taken 2 and 4. When we do the OR operation of it, we get this 110. It is represented in the binary form, and we can see that here the trailing zero is there. So here in the second test case, there are lot many combinations: 2, 8, 2, 16, 4, 8, 4, 16, 8, 16, 2, 4, 8. All these are having the trailing zero. So here in this third sample test case, the elements present are 1, 3, 5, 7, and 9, and when we do OR of any numbers, we can't get a trailing zero in their binary representation, so we have written false. So now let's dry run it with and check what is the approach behind it. Let's say we are given a 1, 2, 3, 5 elements in the array. So for this problem, the catch is that first we need to know about that whenever a number is having a trailing zero when we do OR operation of it. So let's say when we do the OR operation of any two even numbers, let's say 2 or this is OR operator, and 4, let's say. The binary representation of 2 is 1, 0, and 4 is 1, 0, 0. So when we do OR operation of it, we will get a trailing zero. As we know that OR is having the four properties, that 1, 0, 0, 1, 0, 0, 1, 1. When we do OR of it, we will get 1. Whenever any 1 is present, it will give it will be 1 only and 1. Similarly, when we do OR operation of it, we will get 1, 1, and 0. So here it is the trailing 0. So the catch behind this problem is that we need to find the even count of the even numbers. If the count of the even number is greater than equal to 2, means we can get a trailing 0. So whenever if there are more number of even number are present, and when we do our operation of it, we will get a trailing 0. Let's say 2, 4, and 6. So we will do our operation of it, we will get a trailing 0. So this is the very simple approach behind this problem that can be done in O of n time complexity only. As the constraints is very small, you can apply brute force as well, but as the intuition is very easy, and whenever if interviewer asked you about the problem to do this in an optimized manner, so you can explain this. This is a very simple and easy approach. Let's see the code. So here I have maintained the count variable and count the number of the even numbers, and if the count of the even number is greater than or equal to 2, means we can do the OR operation of 2 or more numbers. So answer is true, otherwise false. So now let's discuss the second and third problem of this contest. As in this contest, the second and the third problem is same, just the difference is in constraint only. So we are discussing the third problem, because here I will be explaining the optimized code, which will also run for the second question as well, and it is a more optimized code. So let's discuss the question. So here the question is find longest spatial substring that occurs thrice. So here in this problem we are given a string s that consists of lowercase English letters, and here our task is to find a longest spatial substring which occurs at least thrice. So here the special substring is nothing but, let's say here ABC is not a special string, whereas DDD, ZZ and F is are special because it consists of only one character. So here we need to return the length of the longest special substring of S, which occurs at least thrice, and if it is not possible, then we need to return -1. So let's see the sample test case. So here we can see that the string is consist of A. So 4 times A. So here what we do here is that we will choose A as our substring. So here we can see that in we will choose the first two A, then the middle two A's and the last two A's, and we can see that they occurs exactly 3 times, which is a valid point here to make a valid substring. So here the length of this substring is 2 as A. So we have written 2. Similarly for A, B, C, D, F, no such condition is possible as all the elements are unique here. No character is repeating, so it is mine. We have written -1. Similarly here for A, B, C, A, B, A, here spatial substring is A, as we can see that A occurs 3 times. We can see that A and A. So the length of the spatial substring is 1. So now let's dry run this and understand this with the help of the example. So here I will be taking a string S, which consists of 4 same elements as given in sample test case A, A and A. So here what I will be doing, first I will create a vector for storing which is known as the prefix vector for storing the count of the same elements, length of the longest common substring. So here what we can do, here first only one A is present, 1. As we move to second, we have 2, count is 2, means as index 2 we are having length 2. A, here it count becomes 3, and at last count becomes 4. So this is the length vector uh, which is used to store the length of the spatial substring ending at the ith index. So here now what we do, we will create a vector of multiset. Vector of multiset in the sense which will store uh, the length of the each substring. So here what we do, uh, we iterate through our string S, and what we do, first we will calculate the prefix as we have calculated it here, prefix vector. Now we will store the length of corresponding character in the vector of multisets. So as I have mentioned about the multiset vector of multiset. So here A, first we put the count of A. So here 1. When we reach at this index A. So now what is the length? It is nothing but the count of the consecutive A, that is 2. So here in prefix array we are having 2. So we will push 2 into the set, insert 2 into the set. Similarly, when we reach at this A, count is 3. So at for particular A character, we are having 3. As here in the question, they have mentioned that at least 3 should be there. When we reach at the fourth A, the total count of A is 4 here. But here our size becomes 3. So here what we do, whenever it exceeds the length of the particular character set, it reaches 3 or greater than 3, we need to erase the first element. So first here we will insert the 4. As it reaches greater than 3, it will remove the first one. And now we are having only this much elements in our set. So here what we are doing, we are iterating through the input string S and updating the lengths and multisets accordingly. So what we are doing here is that with the help of the prefix vector, we are storing the count of consecutive A's if let's say here B is present in between. So the maximum count of consecutive A is 2, and at where B is present, that at that index we are storing only 1, because the length of that particular character, we can say up to ith index, what is the count of that particular character we are storing here. So it is nothing but the prefix array, and after that we are iterating the vector, iterating the string and storing it into this set. And this is nothing but this is the vector of multisets with which is storing the length of that particular character. So whenever it reaches the limit 3, we will remove it from the beginning, because we want the best possible longest string. So if we remove the last one, then we are missing the largest, I mean, missing the fourth one. We are removing the first one, and here we get. And at last, we will traverse from A to Z characters and check for the one which is having the window of size 3, and we will return the first most element. So for A, the answer is 2, as the first element is 2, because here A is the substring that we get, which is of length 2. So A, middle 2 and last 2. So we will find the maximum length substring by traversing through A to Z characters. So hope you understand this problem. But if you haven't got the exact actual approach by this, so we will understand this with the help of the code now. So here in this code, what we have done, I have created a vector of multiset which consists of the 26 character only. Rather than creating a map, I have created a frequency multiset which is of 26 character, because we are having only 26 characters. And after that we are having the prefix vector length, which will store the frequency of each and character at index. So here we are traversing through the string. We are checking that whether our consecutive characters are equal or not. So at 0 index we are checking the rightmost element, that whether it is equal or not. In A, as it is equal, so what we are doing, we are updating, incrementing the count of that frequency of that particular character at that index. If it is not equal, then it is ultimately 1. As I mentioned, if B is there, so it is 1. So after that, what we are doing, as in the explanation part, I have inserted the length of that particular character at that particular index into the multiset. So here I have inserted as I have explained with the help of this example. And if it reaches the limit 3, whenever the size of the multiset is greater than 3, at that time we need to erase the firstmost element and limit that multiset size to 3 only. And at last we will traverse to the 26 characters from A to Z and check whichever is having the window of 3, means we got our answer, and calculate the maximum uh, substring, or we can say special substring possible for that, and store it in our answer. And the first element of the multiset is the answer, so we are returning answer. So this is the whole approach behind this problem. Hope you understand all this problem in a very well manner. I have tried to explain it with the help of the example. Even I have explained the code as well. And this is the most appropriate and optimized code for this problem. I hope you got the approach and hope it will be helpful. This is the same code that will work for the second question as well, because the constraints are very less there. So I tried to do it in uh, this 10 to power 5 constraint only, because it will be more helpful to you. So thank you very much for watching this video till this point. Hope you like the video. If you find this video helpful, please don't forget to like, share and subscribe to my YouTube channel, and stay connected for more such helpful weekly contest analysis of Leetcode. Thank you.